One more example with the alternating series test. We have two things we need to try. First of all, does the limit as n approaches infinity of our absolute valued series, in a sense, equal 0, and is any given term less than or equal to the term that was before it? If we can answer yes to those two questions, then we have a convergent alternating series. Clearly alternating because we have what I call the toggle factor in there. The sign alternates back and forth because of this factor. And we are asked to find the first four terms, so let's do it. Here's what I like to do. I like to decide what the signs are first. And so let's plug in just a 1. Plug in a 1 right here. It gives me an even power. Negative even power is going to give me positive. So I'm going to have positive, negative, positive, negative, positive, negative. So positive, negative, positive, negative. So here are my four terms right here. First one's going to be positive. I wrote that in a kind of awkward way, but the first term is going to be positive. Plug in a 1, I get 1 factorial, which is 1, over 1 squared, which is 1. Positive 1. Okay, plug in a 2. 2 factorial, which is 2, over 2 squared, which is 4. And again, plugging in a 1, plugging in a 2 here would give me a 3. Negative to an odd power is going to give me this negative. So yeah, reduce it if you want. I don't feel like it. Plug in a 3. 3 factorial is 6. 3 squared is 9. Reduce it if you want to. And then the next one, plug in a 4. 4 factorial is 24. Good to know. And 4 squared is 16. And then it continues. It goes on forever. So don't just stop it and be like, we found it. Well, no, because the series goes to infinity. So don't just stop it there. You do need to show that it does go on forever. Let's use our two tests, which are part of the alternating series test, to figure this out. So actually, I want to just go ahead and blurt out the answer. But let me point first. Divide by 8, yeah. Divide by, yeah. Okay. It took me way too long to reduce that fraction, didn't it? Yeah. In order of magnitude. Distance from 0. Let's ignore the signs, because that's what we're supposed to do. Like if I just pretended like everything was positive, are these terms getting closer to 0 or further from 0? There you go. We've already answered our question. So here we go. If I dealt with the true nth term in terms of keeping it positive, I would just take this toggle factor out and I would have this. Okay? That negative 1 to the n plus 1 is just going to change my signs. That's all it does. So then the limit, and we just answered this just with a nod and a wink, but here it is. Who's more powerful, numerator or denominator? Numerator, by far. Parabolas are nothing compared to the power of factorials. So, numerator overpowers the denominator? No. No. The series diverges. Actually, you can look at this one from the very beginning and realize that for the same reasons. Numerator is more powerful than denominator. It has a higher magnitude.